Hi, welcome to Darling Fish channel. My name is X-Coco and I'm delighted to continue with the more ratio we started with. This time around, we'll be looking at calculations involving percentage purity. Now let's go over the formulas that we discussed the other time. We said we have N to be equal to mass over molar mass. We also have this formula here, which is the number of entities, the number of particles, which is equal to N times L, that is the mole times the Avogadro's constant. We also have N to be equal to V over Vm, which is volume over molar volume. Then we also have N equals C times V, that is the moles is equal to concentration times volume. So depending on the nature of the question, we can apply any of these formulas. Please take note, any of these formulas here can be applied twice depending on the nature of the question. We can also pick any two from here, so take note of that. Also, percentage purity is equal to mass of pure over mass of impure times 100. So this is what we are going to focus on. Now let's start with a question. Alright, so we have the first question here. Let's go through together. An impure sample of aluminium weighing 2.50 grams reacted completely with concentrated tetraoxosulfate 6-oxide to give 100,120 cm cube of sulfur IV oxide at STP. Now with this question, we have been given a balanced equation. That is 2Al plus 6 moles of A2SO4, giving us Al2 to bracket SO4 subscript 3 plus 6 moles of water plus 3SO2. So this is what we are going to depend on. Now, depending on the nature of the question, we will write the mole ratio between two of the compounds here. So now let's look at what we have in the question. The question says we are to determine the mass of impure aluminum that reacted. But before we do that, we have to look at some parameters from the question. So looking at the question, we have mass of aluminum given. That is the mass of impure. Please take note of this. Whenever the question is talking about mass of impure, that mass is reserved, because if it is impure, we have to determine the mass of the pure. So we have to reserve this figure here. Now we have aluminium given to us. Let's look at the other one that we are going to use. The question made mention of concentrated tetraoxosulfate 6 here, but we have a figure given to sulfur IV oxide, meaning that the mole ratio is going to be between aluminium and SO2. So we have the mole ratio between aluminium and SO2. The fact that this thing was mentioned, the acid was mentioned, doesn't mean that we have to force ourselves to write this. No, we are depending on the question to do the calculation. So now let's move on. Since we know that 2Al and 3SO2 is what we are going to depend on, let's see what will happen. First part of the question is saying that we are to calculate the mass of pure aluminum that reacted. The second part of the question reads percentage purity of the sample of aluminum. Let me give you a trick here. Whenever you hear percentage purity, it tells you that you'll be using the formula mass of pure over mass of impure times 100. Then the last part is also saying that we are to calculate the number of Al3 plus ions formed during the reaction. So we have all parameters given. Now let's start with the show. So over here, we have our aluminium plus 6H2SO4 giving us the 3 products here. So we have to write the mole ratio between this and that. So let's see how it goes. So that will be N of aluminium over N of SO2 ratio 2:3. That is from here, as you can see on the screen. So 2 over 3. Now, when you read the question, you realize that the question is talking about mass of pure, mass of impure. So what we do, if you know or you hear of mass of impure, it means that automatically you have to determine the mass of the pure. So how do we get that? Here becomes mass over molar mass because we are to determine the mass of pure aluminium. Now going back to the question, we're given a volume for SO2, which is 1120 cm cube. We're also given the molar volume, which is 22.4. So down here, we can use the formula V over Vm, which is equal to 2 over 3. So based on this, we can determine the mass here from whatever data we have been given. So now let's break it down. Since this side is talking about volume and molar volume, we can just break that one down and solve. So we have N of SO2 to be equal to V over Vm. That is, we want to get the mole here so that we can easily insert that over here. That is why we are breaking this thing down. So we have V over Vm, which is equal to the volume. Please take note, the volume which was given in the question was in cm cube. So we have converted that to dm cube. That is why it is 1.12 here over the molar volume. And that will give us 0.05 mole. So in place of this, we can have 0.05 mole. Now let's continue. So we have replaced this whole thing here with 0.05. So we can now multiply and determine the mole of aluminium. But take note, when you multiply, that is 2 times 0.05 divided by this 3, that is this side, that is the 3 moving to this side. You divide and you get 0.033 mole. Please take note, the question is not asking us to solve for mole. We want the mass of the pure aluminium. So what do we do? Since we know that this formula is applicable in our calculation, we just have to make M here the subject. That is using the formula N is equal to mass over molar mass. So when we make M the subject, you have M to be equal to N times molar mass. So we insert the mole, that is the 0.033, times the molar mass of aluminium, which is 27, and the mass is 0.89 grams. So this is giving us the mass of the pure aluminium. Please take note of this. Whenever you do the calculation and you have your mass of the pure to be greater than that of the impure, then that is a big worry because we are going to get a wrong answer. So the mass of pure should be smaller than the mass of impure. So what next? Now we move to the next part of the question. Percentage purity of aluminium is equal to mass of pure over mass of impure times 100. So we insert the figures given, that is the calculated value of the pure and the mass of impure that was given in the question. So percentage purity of aluminium is equal to 0.89 over 2.5 times 100, and that gave us 36.0%. So that is how the calculation is done. This is the second part. Now let's look at the third part of the question. We are to determine the number of aluminium ions in this question. So we knowing that the number, which is N, is equal to N times L, we can easily insert our mole, then multiply by the Avogadro's constant. So we have 0.033 times 6.02 times 7 to the power 23, and that will give us 1.99 times 10 raised to the power 22 ions. So that is for the first question. Now let's move to the second question. The question reads, if 15.0 of impure magnesium ribbon reacted with excess hydrochloric acid, liberating 8.96 dm cube of hydrogen gas at STP, according to the equation here. So take note of this equation. That is magnesium plus 2 moles of ACl producing MgCl2 plus hydrogen and gas. So that is what we are going to depend on. Please take note of this. We have to determine the mass of magnesium, that is the pure mass of magnesium, since we have the impure mass given to us. We have 8.96 dm cube of hydrogen gas, meaning that the reaction is going to be between magnesium and hydrogen gas. So take note of that. Now let's move to the question. We are to calculate the mass of pure magnesium that reacted. II, percentage purity of magnesium. So we have all the parameters given to us that we are going to use. Now let's move on. So in our case here, we are to write mole ratio between magnesium and hydrogen. We have 1:1. So N of Mg over N of H2 is equal to 1/1. Now from the question, what can we deduce? We are to calculate the mass of Mg, and down here we're given the volume of hydrogen gas. So down here we'll be using V over Vm is equal to 1/1. We can now insert the figures for us to determine the mass. So we have volume given, we know of molar volume. Then molar mass of Mg is also given in the question. So let's see how we can do that. So we have M over 24, 8.96 over 22.4 is equal to 1:1. So when we make mass the subject, this is what we are going to get. That is 8.96 over 22.4 is equal to M over 24. So mass here is equal to 9.6 grams, meaning that the mass of the pure magnesium is 9.6 grams. So what do? The question said we should calculate the percentage purity of the aluminium. So how do we go about it? Knowing this formula, percentage purity is equal to mass of pure over mass of impure times 100. We calculated for the mass of pure, for which we had 9.6. Mass of impure was given in the question as 15. So times 100 will give us 64%. Thanks for watching and subscribe.